All right, so let's go through our review here for matrices. So looking at number one here, uh, we need to look at the dimensions here. So notice that first matrix is a, whoops, starting off great, 2 by 3. And the second matrix is a 3 by 2. Remember, it's rows by columns. So that means we can't add them together, so there is no solution there. It's impossible. They have to have the same dimensions. So number two, notice we have what 3 by 2s for both of them. So all we have to do is add up the matching up elements. So -1 plus -1, 0 plus 4, 2 plus 0, 2 plus 5, -2 plus 5, and -5 plus 2. That would be our answer. All right, so number 3 here is a scalar on one of them. So what we need to do first is distribute that scalar through. So we'd have what, -20, -10, and -5. I'm not going to copy down the second one, but now we're just going to add them together. So -20 plus -2 is -22. And then we got -10 plus 3 gives us a -7. Then -5 plus 0 is -5. So that would be our answer. So the same thing with this one. So we just got to distribute that scalar through to everything here. So we'd have a -20, a +8, 0, -12. Then we have to subtract. So we're going to say -20 minus 5 would be a -25. We got 8 minus 4 would be a 4. 0 minus -2 would be a +2. And 3 minus -5 would be a +8. So that would be our answer. So number 5 is just telling us we need to multiply everything by 4. We got 4, -20, -12, and 20. We are done. So number 6 wants us to multiply them together. So remember, we need to check the dimensions. The inner dimensions should match up when we write them down. So this is a 2 by 2 matrix. And the second matrix is a 2 by 3. Since these two numbers match up, we can multiply it, and our answer is going to be a 2 by 3. Remember, the only thing you need to be able to do here is use the calculator or Desmos to do this. You do not need to multiply them by hand. So using the TI-84, we would start off by hitting alpha, zoom, and our first one is a 2 by 2. So we're going to leave it like that and hit, oh, there we go. Okay. And now we just have to put in our different numbers. So it was -5, and then 3 6s. Now we're going to hit times. And then we're going to do, it was a 2 by 3, so we're going to hit alpha, zoom again. And we're going to make it a 2 by 3 matrix. And then let's see what the numbers were here. 2 0 3. And then -4, -5, 5. 4. Then we just press enter. So that would be our solution. Remember, if it's different dimensions, you can't multiply them. This will give you an error. It'll tell you a dimension mismatch, I believe, is the error it gives you. All right, so with this one here, let's write down the dimensions. We've got a one row by what, 1, 2, 3, 4 columns. And this would be another one row by 4 columns. So since the two inner numbers don't match up, this is not possible. Remember, order matters too with matrices and the way you multiply them. All right, so your determinant. Remember, your determinant's pretty easy to calculate. It's like you make an x. So we get this times this, -15, minus this times this, -10. So that would be a -5. So that's the value of our determinant. Remember, the determinant's a number. It tells us a little bit. It tells us if we get 0 that we cannot have, it doesn't have an inverse. So this one, we're going to go 5 times 1 minus 1 times negative 3. So the determinant value here is an 8. All right, so with the inverse of matrices, you can type them into the calculator and then you just raise them to the -1 power. Or you can calculate them pretty easily too by just knowing the value of the determinant. So I'm going to do this one by hand. I'm going to do 1 over the value of the determinant. So we've got to calculate the determinant. So that would be -1 times 2 is -2 minus 4 times 8, which is 32. So -2 minus 32 is -34. And then we have to swap these two values. And then we change the sign of these two values. It's kind of sloppy, but you get the idea. So now we can distribute that -1 over 34 through here if we want. So I'm going to distribute that through and I would get -2 over 34. And then 2 negatives are going to make positives, so that's going to be 4 over 34. 2 negatives make positive, 8 over 34. And again, 2 negatives are going to make positive. So now we can reduce this. We can divide the first one by 2. We can divide the second one by 2. The third one has the greatest common factor with 2. Whoops. Divide everything by 2 would give us 4. And then we cannot do anything with the last one. Now, if I wanted to do it on the calculator, I would go alpha, zoom again, and I'm going to make this a 2 by 2. All right, and the values were what? -1, 4, 8, 2. So -1, 4, 8, 2. So now if I want to calculate the inverse on the outside, I'm just going to raise it to the -1 power and press enter. So notice it gives me some pretty nasty decimals. So what I'm going to do now is hit math, enter, enter. And notice it converts it for us. Number 11, let's calculate the value of our determinant. That's 0 minus 0 equals 0. If the value of the determinant is 0, there is no inverse.